When people talk about AI coding systems today, you usually see two extremes. On one side, there are chatbots generating a few hundred lines of code and hoping everything somehow works. On the other side, there are flashy demos that look almost magical, at least until you actually try to use the generated code in a real project. With Presence, we're taking a different approach. The goal is not to create one giant all-powerful model that does everything automatically. The goal is to build a supervised agentic pipeline where different AI models collaborate under human control. The system starts from a simple conversation. The user describes an idea, a project, or a component they want to build. But instead of immediately launching the coding agent, the request first goes through a dedicated functional analysis stage. This phase is extremely important. The AI asks clarifying questions, identifies ambiguities, suggests architectural improvements, evaluates technical constraints, and helps transform a generic idea into a concrete technical specification. In other words, the system tries to truly understand what needs to be built before generating a single line of code. Once the analysis is complete, the system automatically generates a PIF, a project instruction file in JSON format. The PIF contains project goals, technology stack, constraints, required files, acceptance criteria, and planned development tasks. At this point, the project is still not executed. First, the user can inspect the entire plan, verify it, modify it, or reject it completely. Only after approval does the agentic coder become active. The coding system works modularly, file by file. For each task, the system generates code, executes tests inside a sandbox, attempts automatic fixes, validates runtime behavior, and performs up to 3 refinement iterations. Once completed, the generated file becomes available for inspection. The user can read the code, download it, test it live, approve it, request modifications, or regenerate it entirely. This process is repeated for every file required by the project. One of the most interesting aspects of the system is that different AI models can handle different roles. For example, one model may specialize in code generation, another in semantic review, another in supervision and safety validation. During our tests, we observed some very interesting emergent behaviors. In one case, the coding agent generated a perfectly coherent and well-structured Python backend API, but it was completely unsuitable for the actual requirement, which was a front-end widget meant to be directly embedded into a website homepage. And this is where a second model, acting as an architectural reviewer, identified the issue. It didn't simply correct syntax. It understood that the system had built the right solution in the wrong layer. This type of semantic validation is one of the most promising aspects of the entire pipeline. The system can also decide with explicit user approval when a task is too complex for a small local model. In those situations, it can escalate the task to larger cloud-based models through external APIs. But even here, the objective is not to always use the largest possible model. The system continuously monitors task complexity, token usage, estimated cost, and real-time resource consumption. This allows the user to maintain full technical and economic control over the generation process. What we are building is not simply an AI that writes code. We are building an assisted development pipeline where code is analyzed, verified, supervised, discussed, and continuously validated, not a total replacement for developers, but a collaborative ecosystem between humans and specialized AI agents. And in our opinion, this is the direction that will make agentic systems truly useful over the next few years.